By now, you already know how to import flat files using the utils package. The utils package is loaded by default when you start R. Of course, R wouldn't be R if there weren't specialized packages to import your data. In this chapter, I'm going to talk about two such packages, readr and data.table. First, let's dive into the readr package, written by Hadley Wickham. It's a fast and very easy to use package with very consistent naming, while utils is more verbose and multiple times slower. We'll start with installing and loading the readr package, like this. Before, you used read.csv to import CSV files as a data frame, like this call to import the states.csv file. To do this the readr way, you'll want to use read_csv. This will do the trick. The result is pretty much the same. The only difference is that read.csv outputs a tibble, which is a supercharged version of a data frame that Hadley Wickham introduced. You can work with it as a normal data frame, but you can do additional stuff with it. The printout conveniently shows the column classes. In general, all of Hadley's packages work with tibbles. Whether or not they show this convenient printout depends on the packages that you have loaded into your R session. In both calls, the first argument is the path to the file you want to import. Notice that in readr, strings are not imported as factors by default, so an equivalent of the strings as factors argument is not required. Remember that utils also featured the read.delim function to import tab-delimited files. This call imported states.txt. readr also provides a similar function, but it's called read_tsv, short for tab separated value. This is the call you need. Again, no need to specify strings as factors explicitly, which is very practical. Just like in utils, both the read_csv and read_tsv functions are wrappers around the mother import function called read_delim. This table summarizes how the wrapping works for utils and readr. Make sure not to mix things up. I suggest you already head over to the exercises for some practice before we dive into some more customization possibilities for read_delim. I'll see you again in the next video. Remember the states2.txt file from before that uses forward slashes as separators? Before, we've already written this customized read.table call for it. Let's now use readr's more low-level read_delim function to do the exact same thing. As usual, the first argument is the path to the file. Next, the delim argument specifies the character that is used to separate fields within a record. It's the equivalent of the sep argument in read.table. The output corresponds to the output of the read.table call, but the readr version outputs a tibble again. Let's compare the utils and the readr calls here. First off, we didn't have to specify something like header is true, because by default, read_delim expects the first row to contain the column names. It does this with the column names argument. Also, strings are not imported as factors by default, so a strings as factors equivalent is not necessary. To control the types of the columns, readr uses the call types argument, similar to the call classes arguments from utils. Let me dive into the column names first and then talk some more about call types. Column names is true by default. Suppose you have another version of the states file without column names this time, states3.txt. The first line is already a record now. Setting column names to false leads to automatic generation of column names, like in this example. You can also manually set column names to a character vector. The names you pass will be used as the names of the columns, and the first line is read as a record, like here. Next, there's also call types, to control the column classes. If we just import states2.txt, the file with header names, like before, without specifying call types, the column types will be guessed from the first 30 rows on the input. The printout of the tibble shows us the class of each column, which is very practical. The first two columns are character, the third is double, and the fourth is integer. You can also specify the column classes manually. In this call, we enforce the state and city to be a character and the population and area to be both numeric. I used short string representations here. C stands for character, D for double or numeric, I for integer, and L for logical. The result is what we'd expect. The fourth column is a double now. Instead of C, D, I, and L, you can also use an underscore to skip a column. A totally different way to control the types of the columns is through collector functions. Although more complicated, they are more versatile. You'll learn more about those in the exercises. If you're working on huge flat files, say 1 million lines, you might be interested in handling data in chunks of 50,000 lines, for example. This keeps your work tractable, and you can easily follow up on the progress of your algorithms. In readr, you can do this with a combination of the skip and nmax arguments. Have a look at the output of this call. We skip 2 rows and then read in 3 records. There's a problem though. Because column names is true by default, the first row that's read is used for the column names, but this information has been skipped. We'll have to manually specify some column names this time, by setting column names to a character vector. This time, the first 2 rows, so the column names and the first observation, are skipped, and the next 3 observations are read in. Perfect. Let's see our importing skills progress in the exercises. In the last video of this chapter, we'll talk about the amazing fread function from the data.table package. The other package I wanted to discuss is data.table. The key performance metrics for the authors of data.table, Matt Dowell and Arun Srinivasan, is speed. The package is mainly about data manipulation in R, but also features a super powerful function to read your data into R, fread. If you have huge files you want to import and munge in R, you'll want to go with the data.table package. Let's start with installing and loading the library. If you want to learn everything about data.table, DataCamp offers course material dedicated to this package. In this course, we'll stick to the fread function. It is pretty similar to the read.table function you've seen from before, but it's more convenient to use. Let me introduce it with an example. Suppose we have two versions of the states.csv file, one with and one without column names in the first row. Let's call fread on both these CSV files without additional arguments. Fread automatically deals with these two different cases. In the first case, the column names are correctly transferred to the data frame, while in the second case, fread made up some column names itself. Next to automatically handling the names, fread can also infer the column types and the field separators without having to specify these. That's the cool thing about fread. It just works. On top of that, it's ridiculously fast. Of course, the fread function does much more than automatically finding out all column types and conventions in the files you want to read. You can also manually specify the separator, the call classes, the number of lines to skip, and the number of lines to read in manually. Think of fread as an improved version of read.table, which is faster, more convenient, and adds functionality. With these pointers on data.table, it's time for you to get some hands-on practice yourself. Enjoy!